All right, so welcome. Make sure this screen is up properly. We're ready for your review on the periodic table. I'm going to start with a little bit of notes and then I'll give you some directions as to what you need to do at your activity. So let's look at our notes here. I'm going to go down to the bottom where we have some vocabulary. We're going to go through, so this is define. We're going to start with nucleus. Of course, the neutron, is found in the nucleus. And it has a neutral charge. All right, so they're in there, they're found in the nucleus, and they have a neutral charge. The proton is also found in the nucleus, but protons have a positive charge. There we go. Typing and talking and looking at the same time is a little bit odd for me. Electrons are let me get my coloring. Electrons are negative. Charged and found outside the nucleus. And when we get to the modeling at the top of the page, we'll actually go over that a little bit more. So the nucleus, there we go. All right, periods, when you're talking about the periodic table over here, the periods are the ones that are going left to right. They're horizontal. So I'll just put left to right, left to right. And they share elements with same, we'll say, energy shell number. All right, so basically if you're in the first period up here, then you're only going to have one energy shell when we get to the Bohr model. In this period right here, you're going to actually have 2, 3, and so on. Groups, they'll actually go up and down. They're vertical. And there are elements that share similar characteristics. Well, let's just say typing in me is not going on. So there we go, characteristics. So if I ask you what has a similar characteristic to B, boron, then you'll look at, find it on the periodic table, say there it is, and you could actually choose aluminum or really any of the ones in this category. And a similar characteristic would be kind of the same response when you actually bond them with things. All right, so right over here, you can see that we have an element tile, and it's asking for some information. So I'm gonna just make a little draw a text box, because quite honestly, I don't think that it had it here. It would be a little more challenging for me to fill this stuff in otherwise. I'm gonna put a little text box in there so I can type in. And it says first things first. Well, coming from the word over there, all that is the element name. Usually lengthy. Greek, Latin, American, German, after people, places, things. Really kind of impressive. A lot of times, some of them are very hard to pronounce. Nitrogen, not so much, but as you get deeper and deeper, especially into the hundreds, very hard things to pronounce. All right, right up here, this is going to the 7, but that's as close as I can get. That is the atomic number. That also tells you the, let's see if I can just do number of protons the atom has. So if you were to see the atom, see the atomic number, and you're like, hey, there are 7 protons in the atom, and if these are neutral atoms, which all of the ones we're going to be discussing this year are, you'll be able to say, hey, if there's 7 positive protons, there has to be 7 negative electrons. All right, cool things kind of to know. Next, press enter. The little arrows aren't really lining up for my text, but you can definitely figure it out on your paper. You have the symbol. Sometimes it's atomic symbol, usually, or element symbol, but we know that's the symbol. The things to know is the first letter is always capitalized, second letter, third letter, if there is one, are lowercase. That way we know when different elements are coming into play when you're looking at those compounds and mixtures. And then finally, what I have up here is the atomic mass. And that tells you the sum, or the adding number of protons and neutrons. All right, so if this says there are 14, you round it to the nearest whole number. So if that's the sum, meaning the protons and neutrons are being added up, then you actually can go ahead and subtract the 7 protons you already know it has, telling you that there's going to be 7 neutrons in this atom. Very beneficial when you get up to things like this. At the top, we have the Bohr and Lewis dot model. Now, when I was trying to figure out how I was going to do this on the computer, quite honestly, my drawing is not that good. So I went ahead and Googled some things. So I went in and I found I typed in Bohr model N for nitrogen. And I found a couple things. This is one that I kind of liked, all right? Inside the nucleus that they have colored is P protons, there's 7. N for neutrons, there's 7. And then you can actually see the electron shells. So they did it color code. There's 2. Only 2 can be on that first shell. And then they went on 3, 4, 5, 6, 7, giving you the total in that second shell. So that's an interesting way that they put theirs together. If you were to actually take a look, I believe this one right here, a Bohr atomic model for nitrogen. These are kind of clustered in there again, 1, 2, 3, 4, 5, 6, 7. You can see them all. That's impressive. Protons, 1, 2, 3, 4, 5, 6, 7 neutrons. And then again, that first shell has 2 electrons. The next one takes them to their total of 7. So very good. So go ahead and draw one of those, or if you see another one that you like, just make sure that it's that nitrogen representing the protons and neutrons in the nucleus, the electrons in the outer shell, and we're going with 2 can be total in the first shell, 8 in the next, 8 in the third one too. But this one you only needed 7 total, so it worked. The next thing I got is the Lewis dot. So I went ahead and put in here Lewis dot model, and basically I can bring up this guy right here. This is the atomic symbol, and then they have dots representing what the electrons are in the outermost shell. So here in the outermost shell, there's 1, 2, 3, 4, 5 dots, and you probably saw that in your Bohr model. All right, and this guy, Lewis dot structure for nitrogen, put them on this side. It depends on who the person is. That some people go up, down, left, right, up. This person went left, right, up, down, left, as long as you have the appropriate, and it usually boxes in the element itself. All right, so make sure you have at least one of those written in. Come back over here. We still got some more information to fill in. We haven't put in our properties about metals and nonmetals, so I might be able to move this. Oh, look at that. All right, so move this guy over here. And now I'm looking at the periodic table, and the periodic table is not only put into those periods and groups, it's actually divided into metals, all these guys over here, by the zigzag or your metalloids, and then all of them over here, including this guy right here. Those are your nonmetals, and some things that you should probably know about each of those. So let's take a look. Metals, you have that they're malleable. I don't have enough space to really type that much, but basically that means they can be hammered into sheets. They can be bent into different things, hammered and flattened down. All right, you also have their ductile, meaning they can be pulled into thin wires, and they're excellent conductors. So I'm going to just put good conductors of heat and electric. All right, meaning that most of them also have high melting points, so that they'll actually be able to withstand that. Your metalloids, again, metals are right over this huge chunk. Metalloids are pretty much touching all that little stair step. These guys are semi conductors, meaning in some areas they'll be conductors, some areas not. And typically they have characteristics of both, the metals and metalloids, just not as significant as the metals and metalloids do themselves. Finally, you have your nonmetals, very poor conductors. And if they are in solid form, they're going to be dull and brittle. So they're not going to be as strong as your metals. All right, so we have all of this key information. You filled in your pictures there for Bohr model. Here's what you're going to do at your station. At your station, you'll go and you'll find, or maybe you have it in at your person, a bag of cards. You have to sort those. You have to sort them into groups and make sure you can see each card. So probably coming down, you'll have one element, and then you'll have all the cards that go with that element. And then you'll have a second element and all the cards that go with that element, a third element, and so on. So organize them at your table nice and neat, looking at each of them, looking them up, and then when you're done, just flag me down and I'll come around and check and see how you did for that. So good luck. Let me know when you're done.